Hello class, so we're going to do more triangle similarity. So, as usual, copy this whole thing down, and then also make sure that you are doing the word of the day warm up. This is not here for fun. I'm not here just to teach you Chinese. That's what people ask for, and it's also to make us focus and think about what's happening in this lesson. I will check for that also. Alright, moving on now, assuming that you already paused and copied and did all that stuff. Okay, so 中间 means middle. So like when you're talking about the middle of something, like of literally anything, you call it 中间. So the word 中间, you might be thinking, well, what does this have to do with the middle of anything? If you're looking at maybe SAS, you notice, well, A is in the middle, so maybe that has something to do with something. Maybe. Let's check it out. Alright, so SAS, triangle similarity theorem. Two triangles are similar if two corresponding lengths are proportional. Alright, and their included angles. Their included angles, so that's important too, are congruent. So we have two things are proportional and one thing is congruent. So corresponding lengths. Let's see what that actually means. So if we look at this, that's one length, and this is one length. And so I want to say that they are proportional. So I'm just showing you with the marks. They're not congruent. I'm just showing you with the marks that they are corresponding to each other. And now let's use a different color. We see this length and this length. They also correspond. They are proportional. And then we have something kind of special here. We have this thing in the middle. That's congruent. This is what included angle means. That means the angle inside of them that both of them contain. So that means, so SAS, we have a side, we have an angle, and we have a side. We have a side, an angle, and a side. And we have that same side, that angle, and a side. That means these are similar if we have sides proportional and angle congruent. So if we had like a random angle over here, like that angle, that doesn't necessarily tell us anything. We need to have it in the middle there, because in the middle, this tells us about a cross. It tells us that that one is congruent. Not congruent. What's the word? Proportional. So it implicitly tells us SSS. Alright, so let's look at before we do anything, let's match those again. So A, the thing that is across from A is that white thing. So the thing that's across from the white thing here is Z, so Z is there. Okay, B, across from B we have the blue. Across from blue we have Y. And then here, let's see. Across from C we have the yellow. Across from yellow we have X. So ZYX. So ABC is not gonna be XYZ because alphabetical order. So make sure that you're getting the correct angle orders. Alright. Let's use SAS on these and see how that goes. So let's look at these. Our smallest one here is 10. Our smaller one here is 5. Then we have 16 and 8. Let's see, are they proportional to each other? Well, we have 5 to 10. And then we have 8 to 16. What do we do to get 5 to become 10? Well, you can multiply by 2. Can you do that to 8 also? Actually, yes, that gives us 16. So times 2 is going to give us that. Times 2 is going to give us that. So we know that those sides are congruent and proportional. So how about the angle in between? Well, that tells us that it's congruent, so that means the angles are congruent. Angle A is congruent to angle E. So triangle ABC is congruent to what? Well, A corresponds to E, so the first one is going to be E. Okay, where's B? B is here. That's across from the 16. 16 corresponds to 8. So across from 8, we have F. So EF. And then the last one we have left is D. All right, if you need to pause to get it, pause, do that. All right, so let's look at this. Now here's one where we're going to have to use a bit of a, a trick. So remember last time we had two lines intersecting like that, and we were like, we don't see any angles that are congruent or anything. Well, remember vertical angles? So this is going to be a trick that you're going to want to use a lot in geometry. Vertical angles are congruent. This one and this one. Those are congruent. So we have angle DCE is congruent to angle BCA. So alright, we got that. How about the sides around them? Let's see, the smaller one is 4. There. And then the smaller one is 2 there. And we have 6 and 12. So we have 2 to 6. And we have 2 to 4, sorry. And we have 6 to 12. So how do we get there? Well, 2 times 2 is going to be 4. Does that work here? That also works there. So we see that those sides are also proportional. So in an official way, what you can say is CE equals twice of BC. And then CD is twice of AC. Alright, so let's look at those corresponding angles. So we have triangle ABC is similar to triangle what? Let's see, A corresponds to the 2. 2 corresponds to 4. Across from 4 is E, so E is first. Okay, B is there. Across from it is 6. And 6 corresponds to the 12. So we have D. And then the last one is C. So the C one should make sense because they share that angle, right? They share that vertex. So it should kind of make sense that it's probably in the same place. Always, kind of. I would say just always check in case. Alright, the next problem is going to be a bit different. I'm going to have you actually solve for x now. So, let's see. Are these similar? So we have this angle and this angle. Those are congruent. We have those two angles that are congruent. So these are similar triangles. Let me give those names actually. A, B, C, D, E. Let's do that. I accidentally pressed a number. It does that. Alright. So this angle corresponds to this angle. So the triangle ACE is similar to what? Well, we have B. That's corresponding to A. And how about C? C is C. D corresponds to E, so we have that. ACE, BCD. So that means AC is proportional to BC. Okay, well, what else? We want to find X, right? So we need to somehow use the X one. So CE is also proportional then to CD. So let's just do that then. So this basically can turn into, so 72, that's AC. CE is 64. 27 is BC. And then 4x minus 4 is CD. So we can turn it into that. And now let's actually do that out. So I'm just going to write it again here so that we have space. So now we can use that one trick, cross multiplication. And then we get this. Yes, we have big numbers, but we also have Desmos. So if we do that out, we end up with 288x minus 288. I definitely did that in my head. No, I'm kidding. I did that on Desmos earlier. So remember, I did that on Desmos. Just use a calculator for that. If you have something like 2 times 3, that should be pretty doable with your, just like by memory or with your fingers or something. Don't do this in your head. Do it on paper, maybe. Definitely don't worry about this. Just Desmos that. Okay, so now we're back into solving for x. Plus 288. Let's see, that's going to end up being 2016, I believe. Then we divide that out. Then we have x equals 7. Again, the way that I got that, simply just doing out the calculations and using a calculator. I'm pretty sure the answer is 7. So that's what we get there. End of the I do section. Now let's look at the we do section. If you need, again, pause. If the answer is wrong, just put it in the comments or something. But I'm pretty sure I made that correct. Okay. Now we have a few problems where here you have numbers and stuff, but there, no. So let's see why I don't have those numbers. Okay. So these are, this is an isosceles triangle. AB and AC are the legs. So that means we already know that those are congruent. AD is itself, it's congruent also. And let's see. What else do we know? Well, because of the fact that it's an isosceles triangle, these angles are also congruent. Those are the base angles. This is 90, and this is a straight line, so this also has to be 90. So we have quite a bit that we're working with, actually. We have angle, angle. We have angle, angle. So actually, we already have what we need. So we can write this. Actually, no, don't write because. Write the shorthand. Upside down triangle, because angle B is congruent to angle C. and angle BDA is congruent to angle CDA. Therefore, by AA triangle similarity theorem, that's how you can abbreviate that way. Triangle ADC is similar to triangle. All right, let's see. So A corresponds with A, D corresponds with D. So C and B, they correspond with each other. Notice that without any numbers at all and just knowing those two pieces of information, we were able to show that they are similar. So do you always need numbers? No. In math, you will not always have numbers. Oh, that was supposed to be a you tried on your... Okay, well, this one you can try on your own. This is more similar to the other ones from earlier. So try this one on your own. I'm going to give us, suggest 5 minutes. Right now, I'm going to assume you've paused in 3 and then tried it in 2, 1, 0. Let's go over this. A, B, C. Let's see. Well, we're not quite sure of all the proportionality, but what we do know is this. Vertex angles. Therefore, they are going to be corresponding. So that means 5x minus 3 and 2 correspond to each other. Okay, that helps us eliminate that so we're not thinking about it. Now we have this. 3 and 4. 3 is the smaller one. 9 is the smaller one. 4 is the next one. And 12 is the next one. Alright. What can we do with this then? Well, let's see. How are they related? So if we have 3 to 9 and then 4 to 12, how do we get from 3 to 9? We can multiply by 3. Does that work for this? 4 times 3, is that 12? The answer is yes. So, yeah. We know that those are proportional now. And then let's complete the similarity statement real quick. So A, that's the one across from 12. So 12 corresponds to 4. The one across from that is E. B, let's see. That's what the one across from 9. 9 corresponds to 3. Across from 3 is D. So we have D, then C is the last one there. So EDC. Okay. So we need something with AB. So we know that AB is proportional to... Well, I'm going to write this a little bit more to the left. It's proportional to ED. So now we can choose any of the other ones. So AC, let's do that. AC is proportional to EC. How about like that? So AB is 5x minus 3. ED is 2. AC is 9. EC is 3. Alright, cool. Now let's do that whole thing out. Alright, 15x minus 9 equals, let's see, 9 times 2 is 18. 15x equals, after we plus 9 to both sides, add 9 to both sides, that should be 27. Now we can divide by 15. So that means x equals 27 over 15. Can we do anything to this to simplify it? Actually, yes. We can divide by 3 from both top and bottom. 27 divided by 3 should be 9. 15 divided by 3 should be 5. And that is your final answer. Yes, you can have a fraction like that. Yes, the top number can be bigger. Okay, so I want you to solve for x on these three. So I'm going to end the video right here. If you need to pause for anything, again, pause just like usual. All right. Have a good day, everybody.